Hey everyone, Mr. Newman here, and today we're going to learn about slope-intercept form word problems. Just a heads up, there are two kinds of word problems we're going to encounter in this course when dealing with lines. One is the slope-intercept, and the other is standard form. Here, we're going to recognize the slope-intercept word problems because they're going to have a starting value and a rate of change. So first, let's remember what is slope-intercept form. Well, it's y equals mx plus b. And we call it slope-intercept form because the m represents the slope and b represents the y-intercept. Instead of y equals, you can also write f of x equals mx plus b. And that's called function notation. Those two are interchangeable, and here we're actually going to use function notation. Instead of f of x, we'll be using other letters that make sense to us. In context or in word problems, the m always represents the rate of change, and common words that you'll see are words like per or each or every, and that should indicate that that's going to be the rate of change. For the y-intercept, that's the initial or starting value. So if you're given a number at the beginning of the situation, that will be your value for b, and that's your y-intercept. So let's get started. You have started a new bank account with $40. Ooh, I'm going to underline the started and 40 in blue, and plan to deposit $5 each week. Aha, the word each is there. Write an equation that represents the amount of money you have in the bank. Well, the each suggests that's a rate of change because each week $5 is getting put in the bank account. So 5 is my value for the slope or the rate of change. What does that mean in the context? Well, that's the amount deposited per week. Notice the word per is interchangeable in the situation with each. The y-intercept in the context is 40, and that's because that's the initial value or the starting value. That's how much money we start with in the bank. So a function, remember, uses this equation, mx plus b, but instead of m, I'm going to put 5, and instead of b, I'm going to put 40. Notice the rate of change is multiplied by the x value, whereas the initial value is added to that term. The amount of money after 9 weeks is represented by this function, m of 9. Notice m of 9 doesn't mean just 9 weeks. It means the amount of money after 9 weeks. So this is a way of writing the output. To calculate that, we plug it into the function. So 5 times x plus 40, but instead of x, I'm going to put 9. You can type that in a calculator or figure that out, and you'll get 85. So that means $85 will be in there after 9 weeks. For the next problem, for one taxi company, the cost y in dollars of a taxi ride is a linear function of the distance x in miles traveled. The initial charge is $2.50, and the charge per mile is 35 cents. Notice we even have the word initial, so I'm going to underline that in blue, and the charge per mile is 35 cents, so that's going to be my rate of change. So 0.35 is m, and that represents the cost for each mile. The y-intercept is going to be $2.50, and that is the starting cost of a taxi cab ride. For our function, we're going to use our equation again, and instead of m, I'm going to put 0.35 and multiply that by x, and then we're going to add that to 250. To find the cost of riding 10 miles, well, c of 10, that means the cost of 10 miles. In other words, that's the output of the function. And we write the function out, but instead of x, we're going to put 10. When you type that out and solve that, you get $6. So the cost of the cost of a taxi cab ride for 10 miles with this company is $6. For the next one, a figure skating school offers introductory lessons at $25 per session. The word per there suggests that's going to be rate of change. There's also a registration fee of $30. Write a linear equation that represents the situation. Well, the registration fee is a one-time fee. That's the way registration fees work. It's how much you pay to be able to get into the school. So that is a starting cost. So we have our two numbers. The slope is $25, or is 25, and that's the cost of each session. The Y-intercept is $30, and that's the starting fee for lessons. So our function is going to be 25 times x plus the $30 starting fee. To find the cost of 6 sessions, C of 6 actually means cost of 6 sessions. And we're just going to plug in, instead of x, we're going to plug in 6, and you get 180. So 6 sessions costs $180. One of the things we want to do is ask if this is reasonable. We can check and look, let's see here, 6 sessions at $25 each and $30 more dollars. Yeah, that seems like it would be about $180. For the next problem, a tank can hold 30,000 gallons of water. If 500 of the gallons of water are used each day, write the function that represents the amount of water in the tank X days after it is full. So notice a few things. First of all, 30,000 is going to be our starting amount because it says after it's full. The 500 gallons is going to be the rate of change because it's used each day. But notice the word used. Used means that we're losing water. So I'm going to put a star here, and the reason for that is because we need to make the slope be negative. The rate of change is negative because if our function represents how much water is in the tank and we're using water from the tank, we're actually losing that water. So negative 500 is the change in volume of water each day. It's going down 500, so that's why it's negative. For the Y-intercept, that's going to be 30,000. That's because that's how much volume of water is in the full tank. For our function, we're just going to substitute m and b. So I'm going to use w of x for the water. And it did tell us to use x days. So negative 500 times x plus 30,000. W of 7 literally means the amount of water after 5 days. And so we're going to plug, or after 7 days, sorry. So we're going to plug in 7 in for x, and we get 26,500 gallons. We can ask again, is this reasonable? Well, 7 days isn't a lot of time if we're only losing $500 or 500 gallons each day. So 30,000 minus a little bit, yeah, that seems like it would be about 26,500. So our answer is reasonable. Zelda gets a job at a dress store that pays a salary of $90 per week plus $5 for each dress she sells. I'm underlining those two words because this is a tricky problem. Notice our key word is per or each, but one of the numbers has per next to it and the other number has each next to it. So how do we know which number we're supposed to have for the rate of change? Well, we need to keep reading and figure out what it's asking. Write an equation that represents how much Zelda is paid each week. Well, if we're writing how much Zelda's paid for the whole week, then that $90 per week isn't going to be a rate of change. That's actually the starting value or starting cost of the week. That means that we're starting with $90, and it really depends on how many dresses she sells, not how many weeks have gone by. So the dresses she sells, that's the rate of change. If you imagine for a second, does it sound more reasonable to say she sells several dresses in a week, or she takes several weeks to sell one dress? Well, I guess it might depend on the type of store, but most stores, you're going to be talking about how many dresses you sell each week, and that the people will get paid more based on how many dresses she sells in that week. So that means this whole situation is only talking about a single week, how much Zelda's paid each week. If we're talking about just 1 week, the starting value is going to be $90. So the slope is 5, and that's how much Zelda is paid per dress, while the $90 means her starting salary for the week. Now, for the function p of x, 5 times x plus 90 will be the function. And the other thing you can see here is notice the 20 dresses. Since they're asking about 20 dresses, that's going to be the input. And so p of 20 suggests that we're really counting dresses. So we should be looking for per dresses or each dresses, or each dress, not per week or each week. So P of 20, we're going to plug in 20 into for X, and we get $190 is how much she will get paid if she sold 20 dresses in a week. Mrs. Smith takes a pie out of the oven. The temperature of the pie is 320. That's the starting temperature of the pie. If it cools at a rate of 8 degrees per minute, write an equation that represents the temperature of the pie after it's removed. Key word here is cools. You picture why that's a key word? If you said because it makes it -8, you are correct. The temperature is going down 8 each minute. So that's the degrees. The temperature drops each minute. The starting value is 320. So that's our y-intercept. That's the starting temperature. And that makes our function, I'm going to use T of x for temperature. That's -8x plus 320. Find the temperature of the pie after 30 minutes. Well, that's T of 30. That's what temperature of the pie after 30 minutes means. And we'll just plug in 30 in for that equation, and we get 80 degrees. We want to ask, is this reasonable? Well, that is above room temperature. Room temperature is about 70 degrees. So yeah, that's reasonable. It could cool down. If we had a bigger number than 30, say 40 or 50 minutes, that temperature would actually drop down below room temperature, and that wouldn't make sense unless, say, we put it into a fridge or a freezer, and then we could argue that would make sense. But it doesn't say anything about that, so we would want to check and make sure, does this answer sound reasonable? In this case, it does. An aircraft is flying at an altitude of 10,000 feet. The pilot puts the aircraft in a steady dive of 50 feet per second. So the 10,000 feet must be the starting number, and the steady dive of 50 feet per second is the rate of change. Again, I'm going to put a star next to dive. The reason why is because that should make our slope negative. So the change in altitude is what that -50 represents. In other words, the height every second. The 10,000 is the starting height, or the starting altitude of the plane. So our function is going to be a of x equals -50x plus 10,000. And the altitude of the aircraft after a minute, well, wait a second, we didn't say anything about minutes, we said seconds. So here you have to translate 1 minute and remember and understand and recognize that is 60 seconds. So we're not plugging in 1 in, we're plugging in 60 into our function. A of 60 means the altitude of the aircraft after 60 seconds. In other words, after a minute. So after 60 seconds, we plug in 60 in for x, and we get 7,000 feet. Thank you very much for watching.